Good morning, students. Today we are going to discuss how to find inverse of a non-singular matrix by Gauss-Jordan method. By Gauss-Jordan method. Okay, directly I'll move to the exercise. Exercise 1.2, third question. Find the inverse of each of the following by Gauss-Jordan method. So the first subdivision, the matrix is 2 by 2 matrix. It I have named as A. So in the Gauss-Jordan method, first step you have to consider, you have to write A matrix, beside you have to take the identity matrix. So look at this, A is of order 2. So here also you have to consider the identity matrix of order 2. So here A matrix I have written. Here the identity matrix of order 2 is 1 0 0 1. So what we have to do now? We have to bring this A matrix to the identity matrix 1 0 0 1 by doing elementary row transformations. So Gauss-Jordan method, the step is, the procedure is, we have to bring this A matrix to identity matrix by doing elementary row operations or elementary row transformations. So what is your aim? You have to bring this A matrix to identity matrix. So identity matrix order, first element should be 1. Either you can divide this by 2 or you can divide this by 2, okay, or so what I did is I have multiplied this element by 2 so that you are getting 4. Then I'll do the subtraction, I'll get 1. Okay, so here you see the transformation R1, not only this 2, the whole row has to be multiplied by 2. So when you multiply R1 by 2, it will become 4. Here minus 1 will become minus 2. 1 into 2 is 2. 0 into 2, 0. Here I have written R2 as it is. So see now, I have to make this element as 1. Okay. So here I am having 4. Here I am having 5. When I subtract, I'll get minus 1. So I am going to make a change in R1. R1 has to be transformed. So R1 has to be transformed as R1 minus R2. Look at this, I have done in the rough column. So R1 I have written 4 minus 2, 2, 0. And R2 is 5 minus 2, 0, 1. So here the subtraction, so I have changed the sign. Okay, I have changed the sign. So 4 minus 1, 4 minus 5 is minus 1. Minus 2 plus 2 is 0. 2 minus 0 is 2. 0 minus 1 is minus 1. So I have written in R1. Okay. So here what you have to get? You have to get 1. But here I am having minus 1. So R1 has to be multiplied by minus 1. When you multiply by minus 1, it will become 1. It will become 0. 2 into minus 1 is minus 2. Minus 1 into minus 1 is 1. Okay. So here what I did? I have done the elementary row transformation to make this element as 1. So to bring the identity matrix, the next should be, this place should be 0. Okay, so I have to transform now R2. So what is the transformation I have used? R2 implies R2 minus 5R1. So to make this element as 0, here you are having 5. In the place of R1 you are having 1. So the R1 has to be multiplied by 5. So then if you subtract, it will become 0. Look at the transformation. R2 implies R2 minus 5R1. So here what you are having? R2. Write the R2 element here. So I have written here. Then what you did? R1 has to be multiplied by 5. So every element of R1 has to be multiplied by 5. So it will become 5, 0, minus 2 into 5 is minus 10, 1 into 5 is 5. Then in between what you are having the subtraction. So you have to change the sign. When you simplify, you will get this answer. So I have written in the place of R2. So have you got the identity matrix? Not yet. Okay. So this place should be 1. So what I did, R2 has to be divided by minus 2. So when it is divided by minus 2, it will become 0. Minus 2 by minus 2 is 1. And 10 divided by minus 2 is minus 5. Minus 4 divided by minus 2 is 2. Okay. So here you see the form. First I have taken A and the identity matrix. So what at the last step what I have brought? The A matrix into the identity matrix. The identity matrix will become this matrix. So this matrix is the inverse of the given matrix A. So A inverse is equal to minus 2, 1, minus 5, 2. Okay. So we'll see the next problem. So it is 3 by 3 matrix. I named this as A. So which method we are using? Gauss-Jordan method. What's the first step? You have to take the A matrix. You have to write A matrix beside you have to write the identity matrix. Here A is of order 3. So we have taken the identity matrix of order 3. That is in the first step I have written. So what's the procedure? We have to bring this A matrix into the identity matrix. So for bringing the identity matrix, the first element should be 1. Here already 1 is there. So what is the next step? We have to make these two elements as 0. What it is? In the place of 1 we have to bring 0, and in the place of 6 you have to bring 0. Okay, I'll take this R2. If R2 has to be transformed. So here what transformation we have to use now? R2, in the place of R2 the first element is 1. In the place of R1 the first element is 1. When you subtract, it will become 0. So we have to make this element 0. This element is in R2. So I have to do the transformation in R2. What transformation? R2 implies R2 minus R1. Okay, just a subtraction. You look at here. R2 I have written. Okay, next R1 elements is written. In between what you are having? Subtraction. So I have changed the sign. So when you change the sign, you will get the answer. This answer where you have to write? In the place of R2. Okay. So in the next step, you have to make this element as 0. But here you are having 6. The transformation, which row has to be transformed? R3 has to be transformed. It is transformed with which row? R1. Okay, so R1 only you are having 1. So look at this. Here you are having 6. Here you are having 1. In the place of R1 you are having 1. So what you have to do? So this R1, this 1 has to be multiplied by 6. And when you subtract, you will get this place as 0. So the next transformation is R3 is implies R3 minus 6 R1. So see that the rough work. R3 I have written. Then R1 elements has to be multiplied by 6. So it will become 6 minus 6, 0, 6, 0, 0. And in between you are having subtraction. So I have changed the sign and then do the simplification. You will get this as R3. Okay. So what I did? I made already it is 1 is there. I made these two elements as 0. So I have completed the first column. Okay, come to the second column. For bringing the identity matrix, here you should have 1. Already it is 1 is there. So what's the next step you have to do? You have to make this minus 1 and 4 as 0. So minus 1 in which row? It is in R1. So R1 has to be transformed and it is transformed. The transformation has to be done with R2. Okay, because either we have fixed it. So R1 implies, okay, R1 has to be transformed. Look at this place here, minus 1. In the place of R2 you are having 1. When you add, it will become 0. So I have done R1 implies R1 plus R2. Okay, look at the R1 plus R2. Just simply I have added 1 plus 0 was 1. minus 1 plus 1 is 0, 0 minus 1 is minus 1. The same thing you have to do here also. 1 minus 1 is 0, 0 plus 1 is 1, and 0 plus 0 is 0. So I have completed R1. There is no change in R2. I have written R2 as it is. Now what you have to do? This 4 you have to make 0. Then only you will reach the identity matrix. So the 4 where it is in? It is in R3. So R3 has to be transformed. This elementary transformation has to be done with R2, not R1, because it is only fixed. So R3, here you are having 4. In the place of R2, here you are having 1. The 1 has to be multiplied by 4. Then you have to subtract. So it is R3 implies R3 minus 4R2. I have done in the rough work. Look at this. R3 I have written, and R2 elements has to be multiplied by 4. Here I have written. In between you are having the subtraction. So I have changed the sign. Then I'll get this answer. I have written this answer in the place of R3. Now you look at the second column. So it is also in the form of identity. A second column of identity matrix. Now you have to go to the third column. Third column here for bringing this bringing to the identity matrix, the third column here in this place it should be 1. It is already there. So our aim to make these two elements as 0. Okay, so first you take R1. R1 has to be transformed. We have to make this elements as 0. This transformation has to be done with R3, because R3 in this column we have fixed as 1. So when you add these two, you will get R1 as 0. So you have to do the transformation in R1. So R1 implies R1 plus R3. Okay. About 1 plus 0 is 1. 0 plus 0 is 0. Minus 1 plus 1 is 0. In the same way you see that R1 plus R3. R1 element is 0. R3 element is minus 2. When you add it is minus 2. 1 minus 4 is minus 3. 0 plus 1 is 1. Okay. So next what you have to do? We have to make this element as 0. This also has to be done with R3. So look at this, minus 1, here you are having plus 1. When you add it will become 0. So R2 implies R2 plus R3. So here R2 plus R3, 0 plus 0 is 0, 1 plus 0 is 1, and minus 1 plus 1 is 0. The same way here also has to be done. Okay, look at this. So we have taken A, we have brought into the identity matrix of order 3. So beside is nothing but the inverse of the given matrix A. Okay, this is the Gauss-Jordan method to find inverse of a non-singular matrix. So you can do exercise 1.2, third problem, third subdivision, and example 1.19, example 1.20, and example 1.21 as homework. Thank you, students.